So good afternoon. Um, this is going to be one of the ways in which we do our study. We are going to be having these video recordings, which are pretty much the same way we do them in class, whereby I have a slideshow and then we open up our packet tracer and do the respective practicals. So this is the first chapter in the routing and switching, Cisco routing and switching, which is the second chapter of the Cisco networking. So the first chapter is basic device configuration. So in this chapter, we're going to be introduced to basic device configuration, which is a build up on the previous introduction to networks course that we did. So the objectives in this chapter, first of all, of course, we'll have some packet tracer, and we'll be looking at the initial configuration settings of a switch, how to configure switch ports, securing remote access, basic router configuration, and how you verify the directly connected networks that are linked to your devices. So a switch is basically a computer, and when it boots up, it goes through kind of the same way a normal computer would boot up. So the switch attempts to automatically boot by using the information in the boot environment and the boot variable. So if this variable is not set, the switch will attempt to load and execute the first executable file it can find. The iOS operating system then initializes the interfaces using the iOS commands found in the startup configuration file. So please remember, when we are saving the settings on a switch in any Cisco device, we are copying them from the running configuration to the startup configuration. So the iOS, when it is loading, it loads the commands that have been saved in the startup configuration file, which is previously what we copy the running configuration to if you want to make the settings permanent. So the startup configuration file is also called the config.txt and is located in the flash. Now the flash is what they call the permanent memory or the non-volatile memory. RAM is the volatile memory whereby information is lost when there is power loss. However, the non-volatile memory is called the flash, and this memory on a switch is permanent. In the example we have below, the boot environment variable is set using the boot system in global configuration mode command. And notice how the iOS is located in a distinct folder and the folder path is specified. So you use the show boot command to see the current iOS boot file, what it has been set to. So as you see there in the command prompt, we have the command that boots a specific operating system, that is the Cisco C2960 LAN-based image. Normally the image is named as a .bin. So the boot system is the actual command. Flash is the location, that is the storage device where the image is kept. The path to that file is what you see, the C2960 LAN base ending with a slash, which means a folder. And the actual image, that is the operating system file, the iOS file, is the one that ends with the .bin. So what you see there in the boot command is one, the boot system, that is the main command that initializes the operating system to start, the location of where that file is located, which is a flash, the folder where it is actually located, which is the 2960 ending with a slash, to 150-2.se ending with a slash, and then the actual file itself. So that there you see is the path, the actual iOS. So we can just test it by running also something similar on our packet tracer. In here, I'll open up my switch. Okay. So when I open up my switch and open it up, and then I'll run the same command. So let me zoom it up. A minute. Quickly zoom it, make it a bit bigger. Zoom in, also zoom in the command line, and say enable and show boot. So same, okay. So it is showing me the path and the name of the config file and so on and so forth. So we continue. That is the show boot command. Now, for every switch, it has what they call the LED indicators. Like similar to your computers, you have lights. You have a light that shows you that the computer is powered on. You have a light that shows you if the computer has an error, and the light can normally change colors from green to red, and normally all these colors mean something. So whenever your switch is learning, it has a number of indicators that will help you know the status of the switch. The first LED we have is called the SIST. Now the SIST is there to help you know whether a system is receiving power or functioning properly. For as long as the switch is receiving power, the SIST LED will always light up, and normally lights up green. If it is not lighting, it means that you have a problem with power. Either the power supply is dead or you have no power at all. So whenever you have a switch not working and the SIST light is not lighting, you know you have to check whether the system is receiving power or not. And then we have what they call the RPS LED. Now the RPS stands for what they call a redundant power supply. Unlike your Chinese switches, a Cisco switch comes with two power supplies. So I'll quickly show you here. Now I'll show you a quick picture of the back of a switch. Now, if you look at the back of a switch, it looks like that. Okay. At the extreme right, we have a socket where your normal computer cable goes. Yeah, at the extreme right, if you have a look. So at the extreme right, you normally put in the same cable as the cable you use on your monitor. Now this port there is for 240 volts. Normally our normal sockets take about 240 volt. They have a 240 volt rating, same as your computer. It goes straight to the wall socket. Those normal black cables that you see that go like in your monitor or your CPU systems unit. Then there's a second one, this one that you see here in white. Yeah. Now that one there, this one here that you see in white, it has a small triangle above it, just next with all those many pins. That is the second power supply. Now this second power supply normally takes about 12 volts. It's a lower power rating and you need a special adapter to have it run. So normally it takes about 12 volts. So you have that one black and then this rectangular one, the many pins. So those are two different power supplies with different ratings, but both can power the switch. So your switch will always come with two power supplies built in. If one gets a problem, you can connect to another. So this second power supply is like a backup power supply within your switch. So if that second power supply is in use, you will have that RPS lighting up. If it doesn't light up, it means that it may not be in use. Then we have what they call the port status LED, which is the start LED. Now the start LED, its main purpose is when it indicates green, it indicates the port status mode that has been selected, which is the default. Port status can be understood also by the lights associated with each port. So we'll explain that to you. So when this port status LED lights a specific color, all those other ports have to light that specific color, and that specific color means normally something. Then we also have the duplex LED, that is the port duplex LED. This one, when green, indicates a specific port duplex mode has been selected. The port duplex can also be understood by the light associated with each port. Then we have the speed LED. When green, it indicates the port speed mode that is selected, and the port speed can be also understood by the light associated with each port. Then we have what they call the power over Ethernet LED, or the PoE, present if the switch supports power over Ethernet. Now this PoE LED, we won't find in all switches. You only find it on the switches that support what they call power over Ethernet. Power over Ethernet simply means that the same port that gives your computer's network is the same port that will be providing the device attached to it with power. Now you will come across this, especially when you get to installing CCTV cameras. Most of these cameras that you see never have a second cable for power. The same cable that provides network is the same cable that also powers it. But for it to work, that switch has to support power over Ethernet. So for as long as the switch has a PoE LED, it means it supports power over Ethernet. If it doesn't have the PoE LED, it means that those same network ports cannot power any device. And then we have what they call the mode button at the bottom. Now this one is used to move between the various modes. Whenever you click on mode, it will move from sys to RPS to start, duplex, and speed. So you're able to move across all those various modes using the mode button. Whenever you click on the mode button, you can move between those different modes like speed, duplex, start. So what do the various lights mean when you're dealing with what do those various lights mean, especially when you're dealing with the switch? So I'll quickly explain to them. Now, if the RPS port, that is the redundant power supply, is off, it means that the redundant power supply is not in use, or the system does not have a redundant power supply. If it is green, it means the redundant power supply is ready. If it is blinking green, it means that the redundant power supply is up but not available. If it is lighting amber, it means the redundant power supply is on standby or has a fault. If it is blinking amber, it means that the internal power supply failed and now you're working on the redundant power supply. So these lights help you understand what's happening with your switch by just looking at it. If the redundant power supply light is lighting green, it means that it is ready. If it is blinking green, it means that it is up but not available. And if it's lighting amber, it is in standby or having a fault. And if it's blinking amber, it means that the main power supply failed and now you're working on the backup power supply. Then we have the PoE LED. If it is off, it means that you don't have power over Ethernet on the port, meaning that it's not giving you, it's not providing power, or the device that is plugged in it does not need power over Ethernet. If it is green, it means that the PoE port has been selected and it's providing power to the respective device attached to it. If it is amber, of course, it will never light blinking green. It will never light blinking amber. So it will never light blinking green and will never light amber. However, if it is blinking amber, it means that it's not selected and there are some port issues present. And it will never alternate between green and amber. Then when it comes to the start, it means that if the port status is off, it's not lighting at all, it means that there's no link or it has been shut down. Basically, it means that each of the ports, now the idea here is this, the start port, basically when you choose the mode for start port, it helps you understand the lights on each of the ports of the switch. So whenever you press the mode button and move to a specific status, you're able to understand the respective status of all the ports, because the light on the start port will help you understand all the ports on the switch. For example, if you press the mode button to the start status, if there's any port that is off, it means that there is no link on that port or no connection on that port, or the port has been shut down. If the light green, it means that there's a link on the port. If they are blinking green, it means that there's an activity on the port, that is, there's transmission happening, data flowing in and out. If it is lighting amber, it means that a port could have been blocked to prevent a loop. If it is blinking amber, it means that still a port has been blocked to prevent a loop. And if it is alternating between amber and green, there's a problem with the cable, that is, there's a link fault. When the duplex LED, if it is off, the switch ports are running on half duplex. If it is lighting a full green, it means that the ports are running full duplex. And if it is blinking, the colors like blinking green, amber, blinking amber, and alternation between green and amber are not applicable. That is for the duplex settings. So a switch basically either has half duplex or full duplex or none at all. That's why the other colors are not available. Then we have the speed LED. If it is off, meaning that there's no lighting on the port, it means that the port is running at 10 Mbps. If it is green, that is without blinking, a full green, it is running at 100 Mbps. And if it is blinking green, it means that the port is running at 100 Mbps. Now, how do we know this? As I explained earlier, I can go back a bit. A switch port has LEDs. Okay, now these are the LEDs that we see over here: the SYST, RPS, start, duplex, and speed. Now, if you want to understand the duplex settings of each of those 24 ports on your switch, okay, you simply you press on the mode button until you go to duplex. You select duplex. And then you look at all the ports, all the 24 ports of the switch. Now, if you've gone to all the 24 ports of the switch after selecting the mode to duplex, okay, if any of the ports or any of those 24 is off, you know that those ports are running at half duplex. If they're lighting a steady green, you know that those ports are full duplex. Now, if you go back again, press mode, and then go to speed, select speed, you then look at all the 24 ports. If the ports are off, you know that those ports are running at 10 Mbps. If the ports are lighting green without blinking, you know they're at 100. And if they're blinking green, you know that they are at 1000 Mbps. So this helps you know the status of your switch without having to go to the configuration. You simply press the mode button to a specific mode, then look at all the ports and see what their colors they're giving you and how they are reacting. Then we get the PoE LED. If it is off, it means that there is no power over Ethernet. If it is green, there is power over Ethernet. If it is amber, it means that PoE has been disabled. If it is blinking amber, PoE is off due to a fault on the port. And if it's alternating between green and amber, PoE has been denied due to over budget. What is over budget? Over budget is a situation whereby you put there a device that requires more power than what the port can provide. So, the bootloader, like any system, like any computer system, you rely on a bootloader. The bootloader provides access to a switch if an operating system cannot be used because of missing or damaged files. The bootloader has a command line that provides access to the files stored in the flash memory, and the bootloader can be accessed through a console connection, and you do it through a number of steps. The first step is connect a PC using a console cable to the switch port, configure termination software, unplug the power cord, reconnect the cord to the switch within 15 seconds, and then press and hold down the mode button using the system LED until it is flashing green. So you continue pressing the mode button until the system LEDs turn briefly to amber and then a solid green, and then release the mode button. The bootloader will then give you a switch prompt which appears in termination software on the PC, and the bootline command supports the command that format the flash file and reinstall the operating system software and recover any lost or forgotten passwords. And for example, the dir command can be used to view the list of files within a specified directory. So whenever recovering from a system crash, of course, you power on the switch, press the mode button for 15 seconds until all the lights light up amber, and immediately it will take you to the switch prompt where you can run all the recovery commands. So how do you access a switch? So to access a switch, the process is called management access. To prepare a switch for remote management access, a switch must be configured with an IP address and a subnet mask. To manage a switch from a remote network, a switch must be configured with a default gateway, and this is similar to configuring an IP address on any host device. In the figure, the switch virtual interface, the switch is configured an IP address on the virtual interface, which is VLAN 1, and this switch virtual interface is not a physical port on the switch, and a console cable can be used to connect to a switch so that it can be configured initially. So any initial setup of a switch requires a console cable because it will help you put in the IP addresses that you'll use to configure the switch virtual interface. So by default, a switch is configured to have its management controlled through VLAN 1. All ports are assigned to VLAN 1 by default, and for security purposes, it's considered best practice to use another VLAN apart from VLAN 1 for management. So step 1 is to configure the management interface from the VLAN interface configuration mode, and you give it an IP address and subnet mask and apply it to the switch virtual interface of the switch. For example, you can create a switch virtual interface for you as VLAN 99, which will not appear up until it's created and the device connected to that switch port. So the Cisco switch, the switch may need to be configured for IP version 6. For example, before you can configure IP version 6 addressing on a Cisco 2960 switch, you need to enter in the global configuration command SDM prefer dual IPv4 IPv6 by default, and then reload the switch. So we're going to quickly look at how you set up a switch virtual interface other than the VLAN 1 on a switch. And in this case, we'll be looking at a different VLAN from VLAN 99. Sorry, from VLAN 1, sorry. So let's quickly get to it and get to our packet tracer. So here, I am going to set up my switch. So I have a switch here already. So I now get a PC. So I'll first of all show you the process by which you set up the default switch virtual interface, which is VLAN 1. So the IPs we're going to be using are simple IPs 192.168.2.1 and 2.2. So this is how you set up a switch virtual interface for remote management. So the first thing here is, number one, you go to privilege exec mode, configure terminal. We set an enable secret. I'll use a partner like Cisco. The reason why we're setting this enable secret is because you are going to be managing this device remotely, and one of the things it requires is an enable secret. And then we assign an IP address to the default switch virtual interface, which is VLAN 1. We say interface VLAN 1 and give it an IP address 192.168.2.1 and the subnet mask 5.2.5.0, and I say no shutdown. So the reason why this interface comes up is because there are ports associated with this VLAN already, and there's a device that is plugged onto that specific VLAN. Okay, so now the next thing is I enable remote access, and for enabling remote access, I need to set up the virtual terminal. So I say line virtual terminal 0215, and I say password Cisco also, and I simply exit. Okay, so next thing I do is set up my PC. So my switch is 2.1. So my switch is 2.1. My PC will be 2.2. Okay. Now after setting the IP address, I can now try to see if I can remotely manage the switch. I'll say telnet 192.168.2.1, and of course I must for the password, which is the line VTY password, that is the virtual terminal password I set, Cisco, and I'm in. I say enable, ask it for the password, which is also Cisco, which is enable secret, and I'm in. So here I am able to manage the switch remotely from the PC without using a console cable. Okay, but what we've been learning is that it's very important not to use VLAN 1, because VLAN 1 is risky because it's a default VLAN and might be subject to hackers trying to hack into your device. So we need to use a different VLAN from VLAN 1. Okay, so what I will do here is I'll remove the IP address I just gave to VLAN 1. I'll say configure terminal, interface VLAN 1. I'll say no IP address because I want to use this address on another VLAN. Okay, then I create a new VLAN. I say VLAN 20. I exit. So I'll then say interface VLAN 20, and I'll give it an IP address 192.168.2.1. The IP that I removed from VLAN 1, I assigned to VLAN 20, and I put a subnet mask. Now, there's a difference here. I will try to access that VLAN remotely. Close this. So I can say telnet 192.168.2.1. Now it will refuse to connect. Why? Because there is no port associated with this respective VLAN. So under this new security procedure, you have to identify a port that will be used to manage this device, meaning that the PC that tries to manage this switch has to be managing it only on a specific port. When we're using the default VLAN 1, a PC on any port will be able to access and manage the device. However, because we're trying to implement security, we restrict this access to only a specific port. So what we'll do here is we identify the port that we want to use on our switch. So first of all, we need to know what are the available ports we have on the switch. And with that, I exit out of global configuration mode, and then I will go to the privileged exec mode. To the privileged exec mode, and I'll run the command show. Make it a bit bigger. Show IP interface brief, which gives me a summarized information about the interfaces. So these are interfaces we have, okay, from 1 up to 24 and 2 gigabits. So I want to say that 24 is the one that I want to use to be managing this switch. So I'll go to global configuration mode, and I'll say interface fast Ethernet 0/24. Okay, and then I'll assign it to VLAN 20, which is the management VLAN. I say switch port access to VLAN 20. Okay, so after doing that, I then go to my PC, disconnect it from any port that it is plugged into, and then plug this PC into port 24. Remember, 24 is the port that I just changed. So I run the command. Interface fast Ethernet 0/24, and then I say switch port access VLAN 20, and then I got the PC physically and plugged it into. I got the PC physically and plugged it into port 24. So let me show you quickly. So I am now going to get this cable, remove it from whatever port it was, and now I connect this cable to port 24, because it's the one that I have changed the VLAN to. So if you look at my configurations, ignore the messages. Here I said interface fast Ethernet 0/24, and then I said switch port access VLAN 20. And remember, if you look at the configurations, VLAN 20 is the VLAN that I've created for accessing and managing this device. Okay, then I simply go to my PC now and run the same command. Telnet. Remember, before I tried, before changing the port, it refused, and now I can access the switch. Let's go. So let it run, but as you see here, I'm already logged in. I've just run a wrong command. So that is how you set up a VLAN difference. So in my example here, they use the VLAN 99, and me, I've chosen to use something else. At the very end, they copy the settings. So, of course, the switch should be having a default gateway if it's going to be managed remotely, and you have to know what default gateway address to use. And the IP command that you use to set the default gateway is IP default gateway followed by a gateway address. So the gateway address is normally the IP address of the router that connects to your network. Okay, and this can be simply run by using the command IP default gateway. So the command that will help us have a default gateway is simply IP default gateway in global configuration mode, IP default gateway followed by the IP of the router. So I'm using a fictitious name, but this is the command that you use to set a gateway. So the gateway helps you access networks or your device outside its network. So you don't need this IP within the network, but if you want to access your switch to manage it from outside the network, that is the address that you use. So we continue. So of course you can verify configurations by running commands like show IP interface brief. I can show you here. So I can go to the switch, exit, and I can run show IP interface brief. So as you see here, it is giving me all the status of the applications, of the forms of the ports, and at the very bottom here, it shows my VLAN 1 that was assigned an IP address. So you'll be able to see. So please note that the IP address applies to the switch virtual interface is only for remote management access and does not then switch to allow the switch to route layer 3 packets. So the IP that we give the switch, even the gateway, it won't be moving traffic. It's only for remote access and remote management of the switch. So of course we have done that already. I've shown you how to set up remote access on a VLAN on an alternate switch virtual interface apart from VLAN 1. So now we look at port configuration on a switch. Now, of course, we have two main types of communication on all these devices. We have what they call the half duplex and the full duplex. Full duplex communication increases bandwidth efficiency by allowing both ends to transmit and receive data simultaneously. And this is also known as bidirectional communication, and it requires microsegmentation. A microsegmented local area network is created when a switch port has only one device connecting that is operating in full duplex mode. And in these cases, you won't have any, there is no collision domain associated with this switch port operating at full duplex. Unlike full duplex communication, half duplex communication is unidirectional. Half duplex communication creates performance issues because data can only flow in one direction at a time, which often leads into collisions. So with half duplex, you can only send data in one direction at a time. You can either send or receive. Because you can only do one thing at a time, collisions are likely, especially when two devices transmit at the same time. With full duplex, there won't be any collisions because already there is microsegmentation and devices can send and receive simultaneously. Gigabit Ethernet and 10 GB NICs require full duplex connections to operate. In full duplex mode, a collision detection circuit on the network interface card is disabled. Full duplex offers 100% efficiency in both directions, and this results into doubling of potential use of the stated bandwidth. So as long as you're running full duplex, you'll have better performance, and the bandwidth available will be extremely high. And normally, because there are two different lanes, one for sending and receiving at the same time, you won't have collisions. For that reason, any collision detection on the circuit will be disabled. So switch ports can be manually configured with specific duplex and speed settings. The respective interface configuration commands are duplex and speed. The default setting for both duplex and speed switch ports on a Cisco 2960 Catalyst and 36 is auto. the 10, 100, and 1000 ports operates either in half or full duplex mode. When set to 10 or 100, they operate only in full duplex. When set to 1000, when they are set to 10 or 100, they operate only in full duplex mode when it's also set at 1000 Mbps. So at 10, they can be set at half duplex. Then auto stands for auto negotiation. Now it's normally useful when the speed and duplex settings of a device to the port are unknown or may change. When connecting to known devices such as servers and dedicated workstations, it's best practice to manually set the speed and duplex settings. When troubleshooting switch port issues, it's important that duplex and speed settings are checked. Mismatched settings for half duplex mode and speed of switch ports can cause connectivity issues, and auto negotiation failure creates mismatched settings. All fiber optic ports such as 1000 base SX operate at a preset speed and are always full duplex. So we are quickly going to look at how you set up the duplex mode, and my example that I'll be using a hub. So we go back to our packet tracer. Now, in many instances, as you go to the field, you will come across situations whereby you have hubs mixed up with your switches. Okay, so for this, I'll add a hub into the topology, a hub with a PC, and I'll also give that PC an IP address. So you can find the hubs in your network devices, and the hubs, I'll use something called a PT hub, and on this PT hub, I'll add a second PC and connect this PC to the hub, and then I have the hub plug into the switch. Now the hub is plugged onto the switch on fast Ethernet 16, as you've seen. Hope you've seen that. The hub is plugged onto the switch on fast Ethernet 16. Okay. Now let's look at it more closely. A switch by default is a full duplex device. A hub by default is a fully half duplex device. So the big question is, why is there a connection here? So we go simply to the switch, and then let's look at the settings of that port. Remember, it's port 16. So I'll say show IP interface fast Ethernet. Show interface fast Ethernet 0/16. So I want you guys to be very careful with the output and observe what you see. Now, by default, all the Cisco ports on a switch are set to auto, which is auto negotiation. With auto negotiation, the switch will detect the duplex mode of the device that is plugged onto it. Okay. Now, if you look here on this port, it has been set to half duplex. Why? Because it has been set to auto. The switch automatically detected that there was a hub and changed its port to half duplex. Now I want you to see what happens when I change this port to full duplex. Terminal, and I say interface fast Ethernet 0/16, and I use the duplex mode, which is duplex full. Now when I do that, immediately the port disconnects. The reason is because on one end, at the switch side, it is full duplex. Yet the hub only supports half duplex. And what is created here is what they call a duplex mismatch. To fix this issue, I have to either manually change the duplex mode of the port, that is on port 16, and I set duplex half, and when I set duplex half, immediately the port comes up because now the duplex mode is matching. Or I can switch it back to full duplex. When I switch it back to full duplex, it goes off. But now let me set the duplex to auto negotiation. I set duplex, which is the default duplex mode on a switch. Duplex auto negotiation. With duplex auto negotiation, the switch automatically detects the duplex mode of the attached device and adjusts itself to match the duplex mode. So why am I showing you this? Sometimes you may have duplex auto negotiation issues with your switch, in that it's not detecting the duplex mode of the attached device and you have no connectivity. So for that reason, you have to manually intervene and set the respective duplex modes. Another terminology we have is what they call the auto MDIX. When the automatic medium independent crossover is enabled, a switch interface automatically detects the required cable connection, whether it's a straight through or crossover, and configures the connection appropriately. When connecting switches without auto MDIX feature, straight through cables must be used to connect to devices such as servers and workstations, and crossover cables must be used to connect between switches and repeaters. So normally, you use a different kind of cable depending on the connection that you're using. If you're connecting a switch to a switch, you have to use a crossover cable. If you're connecting a switch to a PC, you have to use a straight through. But because the newer versions of the iOS switches support a feature called auto MDIX, the switch is also able to detect the kind of cable that you're using and adjust itself, meaning that you can now connect a switch to a switch with a crossover cable or a straight through cable, because it takes the cable and adjusts itself to automatically adjust. So to examine the auto MDIX settings for the AV specific interface, you can use the command the show controllers Ethernet controller command. So you specify the interface and in privilege exec mode, and you can run the show controllers Ethernet controllers command in the privileged exec mode. So you use the show controllers, just a minute. You use the show controllers Ethernet controller command with the PHY keyword. So this will run it on an actual Cisco switch. So of course we have a number of verification commands that we use. Show interfaces, show startup configuration, show running configuration, show flash, show version, show history. So I'll quickly go run through some of these commands that are used for troubleshooting your switch. So common commands are show version. So show version, of course, is going to tell you about the type of iOS you're running, as you see here. The version, you will see things like amount of RAM you have, and so on and so forth. Yeah, how many ports you have, how many virtual interfaces, the processor, and so on. You run the show run, which will show you the running configuration on your device. Show start, which shows you the startup configuration of your device, which is none. To create it, I have to copy my settings. So when I do that, I can now show start, and it shows me what configurations will be loaded when my system runs. And of course, to remind you guys, copy running configuration and startup configuration is the way you save your settings, because when the system loads, it boots the startup configuration. And if you want it to boot the things that you set up, you have to make sure you run the copy run to start. So there are also other additional commands like show flash, show history. You can really take them and see. Okay, show flash. It shows you the contents of your non-volatile memory. You have in there, you have the startup configuration file saved as the config.txt file, the VLAN configuration file saved as the VLAN.dat, as well as your operating system file, here, the binary image. Then we also have commands like show history, It shows you all the previous commands that you've been running. So if you need to run a previous command, show history will show you all the commands you've been running. And show MAC address table will show you the MAC address table, your current MAC address table on your device, which IPs it has learned. So I'll say show MAC address table. So right now it has learned none, but if I ping, for example, the switch to learn an IP. So those are the basic troubleshooting commands. In your free time, please go through them and test those commands. So running configuration, show running configuration is used to verify if the switch has been correctly configured. For example, you have the output there, it shows you running configuration. Show interfaces is another command that will show you the status of your interfaces, which are down, which are up, and it will show you, for example, show interfaces fast Ethernet 0/18. It will show you the status of the interface and the speed is running, the duplex mode, and so on and so forth. The output of show interfaces is also useful for detecting common media issues. One of the most important parts of the output is to display the line and data link protocol status, as you should see there. The first parameter refers to the hardware layer, which indicates whether the interface is receiving a carrier detect signal. The second parameter, protocol, is up, refers to the data link layer, which indicates whether the data link layer protocol keep alive are being received. And based on the output of the command, it's possible problems can be fixed as follows. If the interface is up and the line protocol is down, a problem exists. There could be an encapsulation type mismatch, there could be an interface error on the other end of the other end, and on the other end could be error disabled, which could be a hardware problem. If the line protocol and the interface are both down, it means there's no cable attached. If the interface is administratively down, it's been manually disabled with the shutdown command, which has been issued in the active configuration. So of course we have show interfaces, which shows you all the interfaces, the extra information about the interfaces, things like the errors, cycle redundancy check errors, the number of frames that are run, the number of collisions. So it gives you much more in-depth information and statistics about an interface. So within those error types, we have the input errors. With the input errors, these ones relate to the total number of errors. They include the runs, giants, buffer, CRC errors, overruns, and ignored counts. With runs, these are normally packets that are discarded because they're smaller than the minimum size of a packet. Giants, they're normally discarded because they exceed the maximum packet size. CRC, normally these are errors generated when the checksums are not the same as the checksum received. Output errors, this is the sum of all errors that are prevented the final delivery of a diagram or an interface. And collisions are normally the number of messages that are retransmitted because of Ethernet collisions. And late collisions are normally collisions that occur after the first 512 bytes of a frame that have been transmitted. So these are all statistics that will be given to you by the show interfaces command. So input errors is typically a sum of all errors on the diagrams that are received on an interface that are being examined. These include runs, giants, CRC, buffer frames, overruns, and ignored counts. The reported input errors are normally outcomes of the show interface commands. Run frames are normally frames shorter than 64 bytes. Giants are those larger than the default size of a frame, which is the 1500, and they're normally larger than the maximum size allowed to be transmitted. CRC errors are normally errors that are within the frames created at transmission. CRC errors usually indicate that the media or a cable error. The common causes could be electrical interference, loose or damaged connections, incorrect cabling, and if you see many CRC errors, there is too much noise on the link, and you should inspect the cable. You should also search for and eliminate the causes of the noise. So CRC errors normally means that the frame itself is corrupted, normally the corrupted frames, due to noise or incorrect cabling or loose connectors. When we have output errors, this is the sum of all errors that have prevented the final delivery, the final transmission of datagrams out of an interface that are being examined. So The reported output errors from the show interfaces command include the following: collisions. This normally happens in half duplex environment, and these ones in half duplex are very normal. However, you should never see any collisions in the full duplex communication. Late collisions, normally these refer to collisions that occur after 512 bits of a frame have been transmitted, and this may be caused by excessive cable length, and these are the most common causes of late collisions. That is, you running cables longer than 100 meters. Another cause could be maybe duplex misconfiguration. So I won't discuss much further on troubleshooting because we've gone through all those respective commands. But whenever you're troubleshooting, you have to go through a number of steps. You look at the interfaces, you look at the output within the interface commands to be able to determine what each of the output means so that you can confirm the cause of the issue. Then lastly, today we are going to be looking at securing remote access. Now, typically when you're accessing these devices remotely, we use the Telnet protocol, which uses port 23. This is an older protocol that uses insecure plain text transmission for both login and authentication. So it doesn't even support things like usernames and passwords when being transmitted. And if you're using tools like Wireshark, you're able to intercept the traffic that is moving between a router or a Cisco switch and a PC that is being used to manage it, because everything is being transmitted in plain text. So Telnet is one of the methods that you access switches and routers to manage them remotely. However, Telnet is very insecure because it transmits everything in plain text. So the solution to that has been Secure Shell or SSH. Unlike Telnet that runs on port 23, SSH runs on port. It runs on port 23. So the difference between Telnet and SSH is that SSH transmits everything in encrypted form. And by transmitting everything in encrypted form, even if the information is captured, only the sender and the recipient can make sense of this information. Okay, so that's the essence of encryption. Only the sender and the recipient can make sense of the information. So there you have a screen of an intercept using Wireshark. All the information is jumbled up and encrypted, meaning that you cannot have your credentials accessed by any threat actor. So we're going to quickly look at how you enable and set up SSH on a switch. So for this, I think I'll just do everything practically, and we'll quickly wrap up this chapter. Okay, so I am now going to take you into the process of how you set up SSH on a device. Okay, so I want to have SSH set up so that this PC uses SSH as the means of accessing the switch to remotely manage it. So the first step is the switch and the PCs have to have IP addresses, which we've already configured. Now we get to setting up SSH. So the first thing here is you have to go to global configuration mode. Okay, now step one, you have to set up a domain name, because SSH is based on encryption keys, and encryption keys are based on domain names. So we'll say domain just a minute, let's confirm here. So step one is back a bit, the steps of setting up okay, the first thing is setting up a domain, which is using the command IP domain name. Just get back to my packet tracer. So I get back to my packet tracer. Now I say IP domain name yci.sc.ug. Okay, that's number one. So also it's important that I give it a host name different from the default. That's a host name yci. Okay, then I set up the encryption. Yeah, say use the command crypto key generate, and I specify here I'm generating the encryption key using the crypto key generate command. It generates the encryption key, and the encryption type I'm going to use is called the RSA. Then we have the modulus. The modulus helps us set the strength of the encryption. 512 encryption means that I'll use 128 bits to encrypt the password. If I use a modulus higher than 512, it means that I'm using a higher, I'm using more bits to encrypt the key, which is more stronger. So I've chosen a modulus of 1024, which is double 512, meaning that a key I create, the higher the modulus, the stronger the key, because I'm using more bits to encrypt the key. If I use few bits to encrypt the key, the encryption won't be strong. But if I increase the number of bits that I'm using to encrypt the key, the encryption will be stronger. So here, the keys have been generated. Okay, so that is step one. Now, when it comes to SSH, you need to have usernames and passwords that you use to access the device. Telling it you don't need to use username and password. So SSH adds the additional layer of security by putting their authentication. So I say name, I'll say Cisco, and I'll set a secret called class. Okay. Then there I have done the bulk of the SSH setup. Now I need to ensure that SSH is the default transport method or encryption method that is used for remote access. So then I go to the virtual terminals, because remember, all remote access goes via the virtual terminals. And then now I specify that SSH is going to be the method of access. So I say transport input SSH. Okay? And that's all I need to do. So then next I test on my PC. To access the switch by SSH, I use the command SSH. I say login as Cisco, and I specify the IP address of the switch. And I press enter. It will ask me for the password of Cisco, which is class. Oh, I forgot just one more command. Let's back to the switch. So I have to specify here, in addition to transport input SSH, I have to say login local, meaning that it's picking the username and password from the switch as the login details. So this here enables this username and password to work. That's why it wasn't working. Okay. So I go back to my PC here. So I press enter. So let me try again. SSH-L Cisco followed by the IP address of the switch. And then I put my password. And I am now logged into the switch. And say enable. I put my secret. And here I am securely connecting to this device. This is how I securely connect using SSH to this device. So that's how we set up SSH. So of course, in your free time, you can try this out and see how it works. So I won't go into the troubleshooting. This you can do on your own, and I will not go to the verification. You can run the show IP SSH to show you the versions and all that is running. Just run it here for you. So I can close this, show IP SSH. As you see here, it's the version enabled, timeout, and so on and so forth. Maximum retries are 3. Let me get back to my slides. So this, I think you can look at in your free time, some of the troubleshooting commands as you read the chapter. So I will not dwell so much on that. Then we get to routers. Of course, in addition to switches, another device we get to deal with on networks is called a router. So of course, we have the same commands that we use on a router as we use on a switch. I'll go through each of these commands shortly. So Cisco routers and switches have many similarities. They support a similar model. They support a similar model operating system, similar command structures, and similar same commands. In addition, both devices have similar initial configuration steps. For example, the following configuration tasks should always be performed. Name the device, distinguish it from the other routers, configure the passwords as shown in the example. So as you see there, of course, configuration of a router and the switch are similar. Okay, so I'll pull up a router into my configuration here, just to show you that everything is pretty much the same. So I'll close this here. So now I want to add a router into the topology. Of course, I use my 1841. So I have a router. I can connect from the first Ethernet 0/0 to any port on the switch. So the commands literally are the same. So I want to quickly go through how to configure a router. And we'll close there for today. So how do you configure a router? The first thing is, how do you add additional modules to a router? Unlike a switch, you cannot add additional modules to a switch, but a router you can add additional modules. The common modules we tend to add during our course are serial interfaces, and how you add a serial interface is by simply switching off the router. Of course, I'll zoom it in. You switch it off, and it has a power button over here. Okay, you switch it on and off, as you see. So the module we tend to add in is a serial port, which is called a weak 1P here, and you can add it by simply dragging it and pressing it there and switching the switch on the router on. So then we can go to the command line interface while it's loading, as you see. So whenever it gives you this menu, this dialog screen, always remember to say no. Always remember to say no in this screen, and it will take you to the menu. The others are the same: enable, configure terminal, host name, can see router 1, same. I can set and enable secret, Cisco has been set. I can set banners like what we did in the previous class. Authorize that's only. Remember, this first character is the start of message delimiter. You have to repeat the same character at the end. So if I can exit to show you, you see now this is my banner. So the same commands that you run on the router are the same commands that you run on the switch. That is the enable, configure, Cisco, what I said. So Cisco, configure terminal, and things like that. So even saving settings is the same. Okay, copy, running config to start config. So show run, same commands. So there's really not so much of a difference. However, unlike a switch which has 24 fast Ethernet interface, on a router you can also view the interface, show IP interface brief, show IP. Normally, a router has just a few interfaces because these interfaces will be connecting to multiple different networks. So that's all for today's chapter. So when you get time, go through this chapter and compare with with a switch. Try to run those similar commands: enable secret, line console password, line PTY password, and so forth. And here I'm setting the banner which I've just shown you and saving the running configuration to that configuration. So one of the distinguishing features between switches and routers is the type of interfaces which I just showed you. When it comes to a layer 2 switch, they only support local area networks, and therefore they have multiple gigabit and fast Ethernet interfaces. Here we have an example of a dual stack where you have both IP version 4 and IP version 6 addresses. So when it comes to routers, they support dual stack. An interface will have two IPs, that is an IP version 4 address and an IP version 6 address. So routers support local area networks and wide area networks and can interconnect different networks together, and therefore support many interface types. For example, you'll have 2 gigabit cards on integrated service routers, and Ethernet interfaces, you have wide area network interface cards. So because routers link different types of networks, you'll have different types of interfaces, unlike the switches. So we'll stop there for today. And when you get time, please go through this chapter, and this should be sufficient for you to be able to attempt the first exam in this chapter.